8th grade lesson 4.3 is graphing linear non-proportional relationships using the slope and y-intercept. So some of you that have gone through some of the live sessions with me or on some of my videos, you keep feeling me hint to where this is going because I can't seem to control myself. I want to keep just teaching it. This is the easy way to avoid, this section is teaching the easy way to avoid having to do the table where you have the x, when x is 0, y is this, when x is 1, run it through the equation, y is that, find 3 points, graph them, and put them on a line. There is an easier way, and this lesson is teaching you the easier way. Yes! So, here we go. Just a reminder, we have the format we're getting much more familiar with as we go, y equals mx plus b, where x and y are the coordinates. Whenever x is this, once it runs through the equation, y becomes that. So that's the xy coordinates. The slope m is your unit rate, and it always is in terms of rise over run. That's going to be important in today's lesson, the rise over the run. You can't sit in a chair and then just start running without rising first, right? So rise happens before run. And then the y-intercept to y-intercept, where the line that this creates, the name, this is the name for a line, wherever that line crosses the y-axis is the y-intercept or y-intercept. I call it the y-intercept to remember the b variable. I call slope m to remember the m variable so that it sticks in my brain. So let me take you through the steps on how you can just take the equation and graph it and not have to do when x equals this, y equals that. So it's really cool. I think you'll like it. So they give us, on page 109, they give us an equation of y equals 2/3 x minus 1. All right. So I have my xy coordinates. My slope m, my unit rate, is 2 over 3. That's a rise of 2 and a run of 3. And my y-intercept is a -1. So I'm going to get on a graph. I'm going to go ahead and put my coordinate plane. All right, there is my coordinate plane. They are in increments of 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Always good to orient yourself with whatever coordinate plane you're looking at to see what increments whoever has set it up is counting in. And so first thing I need to do is look at my y-intercept. My y-intercept is at -1. That means this line, the name of this line is y equals 2/3 x minus 1. That's his name. Interesting name. The name of the line that we're about to graph, it crosses the y-axis at -1. So his points, his xy coordinates are 0, -1. So 0 on the x and -1 on the y. So I'm going to mark him right there. That is one of the points of this line. From there, so step 1, mark your y-intercept. Get this number and mark it on the y-axis. And it was -1. And from there, now I'm going to do the rise over run of my slope m. Rise 2, run 3. So starting at my y-intercept, I'm going to rise 2 and then run 3. These are both positive, so it'll be rise 2, run 3. Rise 2, run 3, like that. So first, rise 2, run 3. I'm going to mark right there. And then one more time. From there, rise 2, run 3, mark right there. Once I have 3 points, I can draw, put a ruler down and draw the line. Pretend that's a straight line. Whoopsie, whoopsie, whoopsie. You get the idea. What this line is saying is that every point along the way is a possible answer for y depending on what x is. And instead of calculating when x is 1, y will be blah. When x is 2, blah, 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 y will be that. This number line is saying, okay, when x is 1, y will be that. When x is 5, y will be that. When x is 1.25, y will be that. Instead of having to calculate all that mess, the line gives every single possible answer for whatever x is, what y will become. These are all a bunch of dots put together to make a straight line, and we put the arrow saying and on forever and ever and ever and ever. So who wants to calculate all those forever and ever and ever? Nobody. So that's why we put the answer as a line. And if that seemed easy, good, and we'll look at another one. Notice, by the way, this was a positive 2/3, positive slope m, so you've got your line leaning forward. I guess I kind of picture it as leaning forward. So it's leaning forward. Positive slope m's will lean forward. Negative slope m's will lean back. So if it's good to know that, because if you graphed it and it came out leaning back and you knew that, you would say, oopsie, I did something wrong. So this is a positive slope m, it's leaning forward, we're in good shape. Let's have another example. Okay, we are given this name of the line, y equals -5/2 x plus 3. Keeping in mind what I just mentioned, a negative slope m, -5/2, is going to be leaning back. So when we graph this, hopefully we see a leaning back line, being lazy, chilling out, because that's a negative slope m. So we should see it leaning back. If it's not, we've done something wrong. So it's always helpful to know that. So starting, actually, even before I go to my y-intercept, I'm going to check the breakdown of my numbers, orient myself with this graph. So every second line is a 4. So this must be counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, like that. Same as on the y number line, 2, 4, 6, 8, 10, 12, 14, 16. So that's how that's broken up. Okay, and then remember our equation y equals mx plus b. B is the y-intercept, m is the slope m. We're going to start, first step to graph it straight off the equation is start at your y-intercept. It is at positive 3. So this line, whatever he's doing, he starts at positive 3. So I'm going to go ahead and mark that. So this is 2, and then right in between the 4, right in the middle is going to be the 3. So I'll mark that there. That's my first point on the line. Then I have a -5 rise over 2 run. Now remember, just kind of going back to last year, this was kind of covered with you. This -5/2 could be -5/2 like that, or 5 over -2, because a negative divided by a positive is a negative, or a positive divided by a negative is a negative. So either way works for me. So I can do the opposite of rise 5, which is drop 5, and then go positive 2. Or I could go positive 5 rise up, and then go in the negative direction 2. Either of those works. We'll do both, just so you can see. So starting at my y-intercept, that's why I put that first. Starting at my y-intercept, I'm going to go the opposite of a 5 rise, which is going to be a 5 fall. So 1, 2, 3, 4, 5. And then a positive 2 run. So 1, 2 to right there. I'm going to mark it. Or if I had decided to do it this way instead, from my y-intercept, I'm going to go up 5, rise 5, 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, right there. And then I'm going to go in the negative direction 2, right there. So I'm going to mark right there. And once I have 3 points on the line, I just have to connect the dots. Oops, I need a pen to do that. Connect the dots with my ruler. Everything that goes on and on that way is a possible answer for y, depending on what x equals. Every point on that line is a possible answer. This is the graphed version of that. So this line's name is y equals -5 over 2x plus 3, or -5/2 x plus 3. That is the name of this line. Notice he is in fact leaning back, negative slope m, so good, we're in good shape. And I wanted to look at one more just for the practice. Again, I start with my y-intercept. It is at a positive 4 on the y number line. I orient myself with this number line, 1, 2, 3, 4, 5. Each line is a 1 increment to get me to 5, 1, 2, 3, 4, 5. Same with the y-axis, so now that I know what that's at, 4 on the y-intercept is going to be here, so that's 0 on the x, 4 on the y. 1, 2, 3, 4, mark it. And then I'm doing my rise over run. First of all, you're probably starting to notice negative, it's going to be leaning back. But you might be looking at this going, wait a moment, hold the phone. That is a whole number. I really need it to be a fraction. Who would have thought you would be sitting here saying, I really need that to be a fraction. I prefer that to be a fraction. But here you are saying, I prefer my slope m to be a fraction. No problem. Make it a fraction. Put a 1 under it. So you have a negative 3 over positive 1. Or it can be a positive 3 over negative 1 because, recall, negative divided by positive is a negative, yay, or positive divided by a negative is a negative, yay. So either way. So I'm either going down 3 over 1, positive 1, or up 3 and negative 1. Either way works. We'll do both. So from here, let's do this one first. Down 3 and positive 1. 1, 2, 3, positive 1. Mark it. And then we'll do this one just so you can see too. This starting again from the y-intercept of 4. You're going to go up 3 and negative 1. 1, 2, 3, negative 1. Mark it. 3 points gives me a line. Every possible answer for this x, giving me y is represented on the line, going arrows tell me forever and ever that way and that way. That is the name of this line. It's leaning back, negative slope, good thing, right? All right, hopefully that is making some sense for you. All right, now I'm looking at the example on page 110, where it says Ken has a weekly goal of burning a total of 2,400 calories by taking brisk walks. That's the starting amount. He wants to reach that goal. The equation y equals negative 300x plus 2,400 represents the number of calories Ken has left to burn after x hours, the unknown amount of hours of walking. He burns 300 calories per hour. 300 calories is being lost, negative 300 per hour. So his goal is to reach this amount. How many hours would it take for him if he's taking 300 away as we go? 300 for every hour. So this equation can help us find that. And so we would graph it. All right, so I've drawn the graph, and as you work those graphs, you also have to recognize what sorts of numbers you are looking at there. This part is representing how many hours, and it wasn't going to be tons of hours, I didn't think. So I did this number line in terms of 2, 4, 6, and 8. So each increment is 1. 1, 2, 3, 4, 5, 6. But this amount was going to be a lot. I needed a number line that could represent these. So this it goes up to 600 right here. So it's 300, 600, then 3 more hundred. So it's 300 each one. So 7, 8, 900, 1,200, 13, 14, 1,500, 1,800, 19, 20, 2,100, 2,400, etc. Okay, so we have to make those number lines work for us. Start with your y-intercept, the starting point, the goal he wants to reach for by the end of week is 2,400 positive. So we're going to mark that right there on the y-axis. Boom. Okay. Then again, we want this to be a fraction because it's a rise over run. So we'll make that a fraction. It is a negative, so we do know that we've got a line that should be leaning back. Also, we need to know too that he's not going negative in calories. He's just going to the 2,400 in calories. So it would stop there. All right, so we're going to go down by 300 because it's negative. So the rise is the opposite of rise, which is down. Down by 300, and then over by 1, run 1. So rise negative 300, run 1. So we're going to go down by 300. Remember, these were 300 increments, over 1, mark it. Oops, let me put a color that we can see. And then down by 300 from that point, again, down by 300, over 1. And once you have 3 dots there, you can simply graph it. And he's not going negative hours either. Now, if I had a ruler, it should tell me exactly how many hours that would take. It looks like it's going to land on the 8, though. So he's losing for every hour of walking. These are the hours. It also sometimes helps to have the labels. I probably should have put those there. Sorry. Hours walking, and this is calories burned. He loses 300 calories for every hour. So it would take him 8 hours of walking to burn the amount of calories he's hoping to burn. If that's what he's hoping to burn, and he's doing 300 at a time, that's how many. So you could see how this could give you pieces of information. Hopefully this all is kind of falling into place for you and makes sense, but seek me out if it doesn't and I will explain it better.